Suppose we have a bag and it contains 5 red, 4 blue, and 2 yellow marbles. If you select 3 marbles without replacement, what is the probability? And I'm going to ask a couple of different things, but in the A part, what is the probability that all 3 are red? Well, that's a basic probability principle problem. Going back to the basic probability principle, the probability of getting all 3 red is a fraction given by the basic probability principle. It's the number of ways you can choose 3 reds divided by the number of ways you can choose any 3 marbles. How many ways can you choose 3 red? Well, order doesn't matter. So that's going to be a combination. It's the combination of, well, how many reds are there? Well, there are 5 reds. So it's a combination of 5 things. In other words, you're looking for reds, taking 3 at a time because you want 3. The number of reds, and you want 3 reds out of the 5 that there are. Down bottom, it doesn't matter which 3 you get, but you're still choosing 3. But looking up here, there are 5 plus 4 plus 2. There are 11 different marbles. So the probability of choosing all 3 reds is the number of ways to choose 3 red divided by the number of ways to choose any 3, which is 5 things taken 3 at a time divided by 11 things taken 3 at a time. Now, when you write out the factorials, remember your calculator doesn't do combinations, but it does do factorials. So that's 5 factorial over 3 factorial times 2 factorial up top, and then down bottom that's going to be 11 factorial over 3 factorial, and 11 minus 3 is 8 factorial. Now the only calculator you can use on the test is the one on the computer. However, for demonstration purposes, so I don't have to try to show the computer screen, I'm actually going to use the calculator on my phone, which in this particular case is pretty much the same. So if I want to calculate, let's clear this off. If I wanted to calculate 5 factorial divided by the product of 3 factorial and 2 factorial, this is what I would do. And again, if you can't see this really well on the camera, just go reproduce it on the computer yourself. But I would say it's 5 factorial divided by 3 factorial equals, and then divided again by 2 factorial divided by 2 factorial equals, and you get 10. Now you need to practice that, and in particular you need to practice that on the computer itself. But what I got at the bottom line after doing all that is that the numerator is equal to 10. Now I'll do the same thing for the denominator. So I'm going to clear, and then I'm going to do 11 factorial divided by 3 factorial and then divided by another 8 factorial. So I've got 11 factorial divided by 3 factorial, so it'll be 3 factorial equals, and then divided again by 8 factorial equals, and I get 165. So that's 10 divided by 165, which actually reduces to 2/33. Now if you did want to change that in, you could do that. So if you were looking it up for a problem on the test and the test gave all decimal answers, then you could plug that in the calculator, and I'm not going to take time to show it on the screen. But if you did calculate that out, it just depends on how you want the answer left. it would be approximately 0.0606. That's the number of ways, that's the probability of choosing all 3 reds. Okay, now I said there was a B part, so let's do that. The B part of that question is,